Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the PV function in Excel to find the price for a zero coupon bond. In any intro finance class, you will have a unit on bonds, and we professors will always have questions where we give you a zero coupon bond and ask you to find the price, the interest rate. If you want to ace those questions, this video is for you. This question is asking us to find the price of purchasing a 1-year zero coupon bond. Now, to get started for any time value of money question, it's best to convert that verbal description into our required variables. So our bond has a maturity of 1 year. We're going to have 1 as our number of periods. The interest rate is 1.5%. I'm going to put in 0.015. The present value, that's equivalent to our price, so we leave that alone. And future value is the amount the bond pays at maturity, also called face value. Like almost all bonds, this is going to be 1,000. Now we go to our B8, next to present value, and type equals PV. Excel helpfully displays our parameters that we need to enter into this present value function. So first one is rate, which stands for interest rate. We would put in our interest rate of 0.015. NPER is number of periods. We have a period of just 1. And payment, PMT, is an interest payments that we pay during the loan, not the final payment. Zero coupon bonds have no payments. That's what the 0 is telling us, so we put in 0. And then FV for future value, that's in brackets. That's because we have a default value of 0, but there is actually a future value. We receive 1,000 at the end of the loan, so we put in 1,000. We can leave type alone. We're done with the function. And so our price is $985.22. Now note, Excel is entering this as a negative number because our future value, our 1,000 here, that was a positive number. The negative present value is, from our perspective, we pay out negative $985 to purchase the bond, and then we receive positive cash flow, the 1,000, once the bond matures. Now, if we want to be a little fancier, use better Excel practices, and most importantly, be able to reuse this Excel file for future questions, we can use cell references. So I'm going to clear out what we hard-coded in here, and I will reference the cells where I entered these values in instead of putting things in directly. So we put in our interest rate in B7. So I'll put in B7. Number of periods was in B6. Payment will still be 0. We didn't have a value for that. And future value will be B9. And of course, we get the same 985 as our present value. And now, if I were to change things, new interest rate for the bond, a different number of months for the length of the loan, potentially a different future value, although that probably will not change for bonds, I can put these in changes in here, and my present value will immediately update. So let's say our interest rate, or yield to maturity, is actually 2.5%. And boom, our present value is now updated. It's going to be a little bit lower because our interest rate is now higher. There's an inverse relationship there. And we can do that for any of those 3 parameters. Now, mathematically, this calculation is exactly the same as just finding the interest rate for a single cash flow. If you want to review how to do that without the zero coupon bond terminology, I've included a link in my video description covering that process. It's the same function. With this single function, you can now find the price of any zero coupon bond your professor might throw at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find it too. Happy studying!